The reaction is benzene plus oleum in presence of heat, high temperature, it gives 1,2-disulfonic acid. Here the electrophile is the free sulfur trioxide, SO3. Toluene undergoes sulfonation in the ortho and para position. The next, Friedel-Crafts alkylation. This reaction involves the action of an alkyl halide, an alcohol or an alkene on aromatic compound in the presence of anhydrous aluminum chloride, which is an catalyst. The reaction is C6H6 plus CS3Cl in presence of anhydrous AlCl3. It gives C6H5CS3 plus HCl. Next, C2H6 plus CH2Cl2 in presence of anhydrous AlCl3 at high temperature, it gives C6H5 whole twice CH2, the diphenylmethane plus HCl. In case of chloroform, the reaction is C6H6, the three molecules of C6H6 plus CHCl3 in presence of anhydrous AlCl3 at high temperature, it gives triphenylmethane C6H5 whole thrice CH plus HCl. In case of alcohol, the methyl alcohol, the reaction is C6H6 plus CH3OH in presence of anhydrous AlCl3 at high temperature, it gives C6H5CH3 plus water. Now the mechanism. The reaction mechanism involves regeneration of electrophile. Here the electrophile is alkyl carbonium ion, RCl plus AlCl3. It gives the alkyl carbonium ion plus AlCl4 minus. The formation of carbocation, the slow process. Then the transfer of proton from the carbocation to form the final product. This is a fast process. It is important to note here that in higher alkyl halides, the alkyl carbocation formed at the initial stage may undergo rearrangement to form the more stable 2 degree or 3 degree rearranged carbocation, and thus the unexpected alkyl benzene is formed as the final product. For example, benzene when treated with N-propyl chloride gives isopropyl benzene rather than the N-propyl benzene. The reaction is benzene plus N-propyl chloride in presence of AlCl3, it gives isopropyl benzene. It is due to the rearrangement of the N-propyl cation, the 1 degree, to the more stable isopropyl cation, the 2 degree. Now it is more stable isopropyl cation that attacks the benzene molecule to form isopropyl benzene. Now the next, the Friedel-Crafts acylation. This is quite similar to alkylation. It involves the reaction of benzene with the acid chloride or acid anhydride in presence of the anhydrous AlCl3 to form ketone as the final product. The reaction is benzene plus acetyl chloride CH3COCl plus in presence of anhydrous AlCl3, it gives acetophenone plus HCl. The mechanism involved here is the electrophile is the acylium ion, the acyl cation, RCOCl plus AlCl3, it gives RCO plus AlCl4 minus. The formation of carbocation and then the final product. The first part is the slow reaction, the second is the fast to give the final product. It is important to note here that the mono-substituted alkyl benzene, for example, the C6H5CH2CH3 are generally prepared, although generally prepared through acylation process rather than the direct alkylation. One of the reasons is that in direct alkylation, as soon as one alkyl group is introduced, the benzene nucleus becomes more active than benzene itself because of electron releasing character of the alkyl group, and hence further substitution takes place leading to the formation of polyalkylated product. On the other hand, in acylation, as one acetyl group, that is CH3CO, is introduced, the ring is deactivated and hence the introduction of the second acyl group becomes difficult. The monoacylated benzene is then easily reduced to monoalkylated benzene by Clemmensen's reduction. The reaction is benzene plus acetyl chloride, it gives the acetophenone, which further reacts in presence of zinc, mercury and HCl to give ethyl benzene. Later on, Fetal Kraft reaction was extended for preparing other compounds by replacing alkyl and acyl halides by other reagents. For example, benzene react with carbonyl chloride in presence of AlCl3, it gives benzoyl chloride. The same manner, benzene reacts with chloroformamide in presence of AlCl3, it gives benzamide plus HCl. Toluene on fetal Kraft reaction gives ortho and para substituted products. Toluene plus CaCl3, toluene plus CH3Cl in presence of anhydrous AlCl3, it gives orthoxylene and paraxylene. Next, the Gattermann-Koch aldehyde synthesis, where the benzene reacts with carbon monoxide in presence of diHCl, where the benzene reacts with carbon monoxide and dry hydrochloric acid in presence of dry AlCl3, it gives the corresponding product benzaldehyde along with the liberation of HCl gas. Here the electrophile is CHO group formed according to the reaction CO plus HCl in presence of AlCl3, it gives HCOCl. The HCOCl plus AlCl3, it gives the HCO group HCO plus AlCl4.